Hi children, welcome back to the science class today. Today we are going to learn about materials, metals and non-metals. It is part 2, that means second session we are going to do. It starts from the page number 46 of your textbook children. Children, we are going to learn about some chemical reactions or chemical properties of metals and non-metals. In the previous class what we studied, that all we are going to have some bird view of this. That means let us revise a little bit what we are going to learn this one. In this chapter, we are going to learn about physical properties of metals and non-metals. Already have learned chemical properties of metals and non-metals. That in that one, reaction with oxygen, reaction with water, reaction with acids, reaction with bases, displacement reaction, uses of metals and non-metals. Okay, these are the learning points in this chapter. So in the first session already we have learnt about physical properties of metals and non-metals. Remember, so various sounds you have learnt, isn't it? Metallic sounds, non-metallic sounds, lustrous and non-lustrous, malleable and ductile, all these properties you have learnt, no? So in the second session we are going to learn about chemical properties of metals and non-metals. In that, a reaction with oxygen, reaction with water, reaction with acids. Okay? So in third session, reaction with bases, displacement reaction, uses of metals and non-metals. So these are the learning points what we are going to learn in different sessions, children. Now let us go to learn remember or recall what we learned in the previous session. Matter exists in solid, liquid and gases. That we have learned, no? We have seen how the matter is exists in this one, the nature. So first of all, what is matter, children? Matter is anything that occupies space and has mass. That you have learnt in 7th standard. 6th and 7th standard you have learnt about this, isn't it? And also, matter in the nature exists in the form of solid, liquid and gas. Okay, matter is classified into metals and non-metals. They are mainly classified into two groups, metals and non-metals. One more is there, metallite. About that you will learn in the later classes. Okay, so physical properties of metals and non-metals also we have learned. They are malleable, ductile, sonorous, lustrous, etc. we have learned, and both we compared also, isn't it? So now let us see. In the previous session we have learned about the metals are good conductors of electricity. Now let us see today non-metals how they will do. Okay. Look at this. Madam is checking for the metal. It is a conductivity. It is conducting. It is a good conductor. That's why light is glowing. Next you see bangle. It is a glass. Bulb is not glowing. That means it is a bad conductor. It is a glass. That is also not conducting. No light. The tester front portion was conductor. Now back side you see the screwdriver to do the electrical work. No, so the metal piece is coated with plastic, which is a bad conductor. It is not conducting electricity. Now see the matchstick. Look at the matchstick. Whether it is conducting electricity? No, it is a bad conductor. Wood. It is a wood piece. No, that's why it is not conducting. Here is the plastic part of the cutting player, so it is also not conducting. See the metal part. You can see the light. See how it is glowing. It is a conductor. So plastic is bad conductor. That is good conductor. Now see this one, hairband. It is a bad conductor. Made of cloth. Nylon cloth. Okay. So candle, wax. It is also a non-metal and it is not conducting. See the wood, it is not conducting, it is a bad conductor. See, now we are going to check the pencil. Look at this one, children. The lead is a non-metal but conductor. But here, that is inside the wood. So when we conduct this one, it is not conducting because of wood. Wood is a non-conductor. Now madam is checking with the cloth, handkerchief. Bulb is not glowing now. It is a bad conductor. The rubber It is also non-conductor. Now let us see the properties once again. What the things what we learned. Let us have a brief summary of this one. Metals generally solids. Non-metals can be solid, liquid or gas. Metals ductile. Metals can be ductile. That means they can be drawn into thin wires. Okay. Non-metals non-ductile. Metals are malleable. That means that can be beaten into thin sheets, but it is not possible in the non-metals. Non-malleable they are. Metals produces ringing sound, that's called sonorous, the characteristic sound of the metals. But non-metals or non-sonorous, they will produce the sound but not the ringing sound. Okay, we can identify the sound itself whether it is a metal or non-metal. Metals are usually lustrous and non-metals are non-lustrous. Metals are having high melting point. Non-metals are low melting point. Generally, metals are good conductors of heat and electricity, whereas non-metals are bad conductors of electricity. Some exceptions are there that we have learned in the first session itself. Okay, understood, children? This is the brief summary about the first session what we have learned. Let us go for this one. See, this is the arrangement of elements which are available in the nature. Usually we know that nearly 98 elements are occurring in the nature. 98 elements. Among them, most of them are all metals only. Metals, non-metals, and some are metalloids are there. That we are going to learn in detail in the higher classes, children. So now we'll come to the today's session number 2, that is chemical properties of metals and non-metals. See, we cannot, by the experiments what we have learned, we cannot decide by physical properties whether the material is metal or non-metal. We cannot confirm because there were exceptions, no? See, sodium is a metal, but it can be cut into pieces with the help of a knife. They have high melting point, high boiling point also we have learned. But when you come to the gallium and cesium, they are not like that. They will melt at the room temperature, but when you keep in the hand, it will start melting. Some exceptions are there. So, to decide whether it is a metal or non-metal perfectly, we have to know their chemical properties, children. So, let us see the chemical properties of metals. Now, see the gate. What happened? See how nice, no? First it was shining, but now it is rusted. Iron, when exposed to the air or moisture, air and moisture, it undergoes rusting, a chemical reaction, and it forms rust. That means iron combines with oxygen to form rust. Here see the tie. You might have seen the tie car. When you brought it was shining and lustrous. Now you see how it happened. The condition of this car is pathetic, that is rusted. So when it is exposed to the moisture in presence of oxygen, it happens like this. See, even some metals such as silver and other things also, they will lose their lustrous. Why? Because of some chemical reactions are going to be happen here. So what type of chemical reaction? So in the moisture, in presence of moisture, iron reacts with oxygen to form the respective oxide. Here silver when exposed here, it reacts with the sulfur which is present in the atmosphere and forms a green coating. Light green or purple color coatings are going to form. They will lose their shining surfaces. So because of coat is formed because of the metal reacted with the some of the other non-metals. Now see, iron plus oxygen plus water. What is giving? Iron oxide. Iron, Fe, ferrum. Full form of iron is Fe, ferrum. Oxygen plus water, in presence of water, it is reacting to form iron oxide. Fe2O3 is going to be formed. This is the equation for rusting of iron. Children, how will you come to know what is the property, what is the nature of this iron rust? Whether is it acidic or basic? So how to check, you know that? So if it is acid and base, they will show proper properties here. See here, I am showing you the papers, that is blue litmus and red litmus I am showing here. So these papers when you dip in acid or bases, they will change the color. So they are called indicators, isn't it, children? Now, by using this one, we can identify whether the rust is acid or base. Okay. Now, let us see the test. One test for this one. Now, I have some iron nails. In this one, I have kept iron nails here, which are rusted. So, in your textbook, they are given, scrape the rust and collect 1 spoon of that one and test it. But I am not. I have taken the rusted iron nails in this one. I am putting in the glass. So, I am adding water to this one. I am shaking. So, the rust is going to be dissolved in it. So, a little bit I have to wait for that to dissolve. So, by shaking I can dissolve it in a little bit. Now, let us check it for whether it is acid or base. I am going to check it. Now, I think some of the rust, it is dissolved in this one. Now, I am going to check it with the litmus paper. Now, I am using red litmus paper. See, children, this is red litmus paper. See, this is red litmus paper what I am having. So, now I am going to dip in this one. See, is there any change here? No change you are seeing, no? Red litmus paper is like this only. So, usually what happens when you dip the red litmus in the base or acid? Bases will turn red litmus to blue, isn't it? Now, let us see whether it is going to be changed, what is going to happen. So, little I have to wait for some time. It has to, see, I am dipping, children, once again in this one. See, what I have taken first, it was red litmus. Now, see the color of this one, it turned to blue color. Look at this, children. That means, what is the nature of rust? Rust is a base. Rust is a base. Got it? So, this is the red litmus paper what I have took in the beginning. Red litmus paper, and dipping into the rust dissolved in the solution, it turned to blue color. So, now metals react with oxygen, I told you. So, let us see here the teacher is using spirit lamp and burning magnesium ribbon. Magnesium is a metal, no? When it is burned, what will happen? You see? Now, let us see the experiment what they are doing. Okay. Since it is outside, we are not able to see the flame.
It takes little time to catch fire. Children, this is a question for you to think and answer.
It is taking little time because it has high
Now the
ignition
magnesium
temperature.
layer is burning with a sparkle. The powder is falling on the watch glass. You can see the white colored powder falling onto the watch glass. You can also see lot of fumes going on, coming out from it. So when you are doing the experiment, you should be very careful. Now the sir is taking this powder and dropping gently into the beaker. Now he is stirring the solution very well, so that the magnesium oxide that is formed will dissolve in the water. Now it has sparingly dissolved in the water. This is red litmus paper. So let us see what happens when a piece of red litmus is dropped into this solution. We have to wait patiently for the experiment to take place. Sir will also stir that. We will wait and see. Can you guess what will happen in this? Guess, children. Whenever we are doing experiments, we should have patience and also caution. You can see it has beautifully turned into blue. Did you see, children? So the solution has become alkaline in nature. I hope you understood that when magnesium burns in air, it forms magnesium oxide, and the oxide that dissolves in water forms the base magnesium hydroxide. That is why the litmus paper has turned blue in color. Thank you.
Now children, you have seen the experiment, how nicely. First we have seen rust, iron rust we have seen. Iron rust, when we dissolve in the water, that turned red litmus to blue color. Similarly, magnesium ribbon, that is magnesium is a metal. A small ribbon is a thin wire like that they have made. The flat wire they have made, no, that is called magnesium ribbon. And when it is burned in air, that is oxygen, it forms magnesium oxide. Children, in the experiment you have seen, it took much time to heat up. Sometimes what happens, magnesium which is exposed to the atmosphere, it forms a coat of magnesium oxide. So because of that, it will not catch fire easily. It will not catch fire easily. That's why we have to scrap it and rub it with some of the knife or something. We can rub it and when heat. And also it has high ignition temperature. That's why we have to wait for the metal to catch fire. It has to be heated up, then it will catch fire. Catch fire means once it catches fire, it forms the magnesium oxide. So when it is dissolved in water, what happened? It formed alkaline solution. It is a base. So when base it is formed, then red litmus turn to blue color. Here magnesium plus oxygen giving magnesium oxide. So the powder, white powder what you have seen, that is nothing but magnesium oxide. Now reaction with oxygen, with what happens to the, with some of the materials we are going to see. Magnesium you have seen. So similarly, some of the metals such as copper, when heated in the oxygen, it forms cupric oxide, CuO. Copper oxide is going to form. Balanced equation is 2Cu plus O2 gives 2CuO. That is the powder, brown powder is going to be formed here. Similarly, we are going to see metallic oxides also. So here copper plus oxygen gives copper oxide. So now when you heat the aluminum in the atmospheric air, 4 aluminum atoms combines with 3 oxygen molecules to form 2Al2O3. That means aluminum plus oxygen on burning gives aluminum oxide. That means aluminum reacts with oxygen to form aluminum oxide, children. So that is a white powder. Right, sometimes it is a crystalline powder is going to be formed. So when we heat some of the metals, that will give a respective colors. They will burn with the respective color. The flame will have different colors. Look at this one. Lithium, it is a metal. It gives the color reddish in color. Strontium, some pink in color. Sodium, yellowish red in color. Copper, bluish green color it gives. Potassium, reddish white color is going to give. So different colors they are going to produce. So let us see some of the other reactions. Sodium reacts with oxygen to form sodium oxide. So here potassium plus oxygen. Potassium is reacting with the oxygen to form potassium oxide. 4K plus O2 gives 2K2O. So here Na2O, sodium oxide, plus water, when it is dissolved in it, it gives sodium hydroxide, NaOH solution. Here we are showing some of the alphabets in between. No? Na2O, S we are written, H2O, L is written, NaOH, aqueous, AQ we are writing. So this shows that sodium oxide is a solid, water H2O is liquid, and sodium hydroxide what we are using, that is aqueous solution. Aqueous solution that is present in the form of liquid only. Sodium hydroxide in the form of liquid is called aqueous solution. So by this one easily we can identify which are the chemicals, which are the elements reacting with each other, or which are the compounds reacting with each other to form the products, and what are their physical states. That also can be shown here. So it helps us to understand clearly. That's why we will write like this. Now potassium oxide K2O plus water, then potassium oxide is going to obtain, that is 2KOH is going to be obtained. K2O plus H2O gives 2KOH. 2KOH solution is going to be formed here. So K2O is a, potassium oxide is a solid, water you know that it is a liquid, and potassium hydroxide which is formed is aqueous, that is in the water, liquid form it is present here. That is aqueous solution. Children, are you able to remember here? Clearly how to note down this one. Now let us go to next, especially non-metals we are going to see. So non-metals react with oxygen to form non-metallic oxides. Usually non-metallic oxides are acidic in nature. They are acidic in nature, children. So which are the non-metals example? You see here we are going to see one activity which is given in your textbook, that is sulfur. So when you burn the sulfur, what will happen? So here we are going to see the experiment which madam is showing now. So sulfur is taken in the deflagrating tube and it is heated, and when it catches fire, it is kept in the jar which is closed. Why we are closing? To collect the gas. So the sulfur is on heating, it catches fire and it forms sulfur dioxide. Sulfur reacts with oxygen to form sulfur dioxide. See, it is collected in the jar. So next we are adding water to it. So after adding water, we will shake it. Shake well. Why? Because by shaking, it will dissolve in water. Sulfur plus oxygen plus water, all three. So sulfur plus oxygen gives sulfur dioxide, and sulfur dioxide gives H2SO4. Sulfurous oxide is going to be formed. So when you dip red litmus paper, it will not change. When you dip blue litmus paper into this one, that will change to red color. So acids will turn blue litmus to red color. Sulfur dioxide, SO2 plus water H2O gives sulfurous acid, that is H2SO3. Here is an activity, children. You have to identify metal and non-metallic elements in the given compounds. Children, look at this table. We are given list of bases and list of acids are given here. Now let us see base. In the base, which is the metal is present. In the acid, which is the non-metal is present here. Let us see the first, we can go for bases. So calcium hydroxide is a base. Calcium is a metal. Sodium hydroxide, which is a base, in this one the metal is sodium. Ferric oxide, that is iron oxide, so metal is iron. Potassium hydroxide, here potassium is a metal part. So acids, when you come, sulfuric acid, H2SO4, here sulfur is a non-metal. Nitric acid, HNO3, here nitrogen is a non-metal. Okay. Hydrochloric acid, hydrogen is a non-metal. Carbonic acid, carbon is a non-metal here. So acids and bases, you can see all metals react with the oxygen to form their respective oxides or hydroxides. They are bases. So now let us go for reaction of metals and non-metals with water, how it will form. Look at this, children. What is this? That is sodium metal. Shining metal, no? See how it is shining, and it is kept in a bottle and stored in kerosene. It is kept in bottle and stored in kerosene. So now let us see the experiment, how it will react with the water. So here I have taken sodium in the base, and now in the beaker we have taken water. See what is happening? See how vigorously it is reacting. By hissing sound it is going to react. So it liberates hydrogen and catches fire because it is an exothermic reaction. How nice, no? So sodium reacts with water vigorously to form sodium hydroxide solution. So when we check for the acidity or basicity, what is going to be happen? So here it turns red litmus to blue color because it is a base. So now under one non-metal, it has to be stored in water. Why? The phosphorus, it is highly reactive non-metal. Highly reactive metal is potassium and sodium. Highly reactive non-metal is phosphorus. So this has to be stored in water. Children, Some metals will not react with water as the sodium will react. So, for this one we have to subject to the heat, that means steam we have to pass. By passing the steam it will react with the steam. See here, this is the setup what is showing here. So, it is in a hard glass test tube. We have a glass wool which is dipped in the water and metal piece is kept in the hard glass test tube. So, this is the metal piece, metal wire is kept here, So, metal wire we are kept in this one, and when we heat, the steam is going to produce that steam. When it passes through the metal piece, that will react and it will liberate one gas, that is hydrogen gas is going to be liberated. How to check the hydrogen? Whether the gas is given, whether it is hydrogen or oxygen or which one, how will you check it? So, we can check for the hydrogen by means of a pop sound. Here hydrogen is going to catch fire suddenly. Hydrogen is a combustible gas, that. When you bring a burning splinter or burning matchstick near the mouth of the test tube, it makes pop sound. So, there is the test for the hydrogen, children. Next we go for reaction with the acids. Non-metals, how they will react with the acids. See, magnesium, aluminum, zinc, iron, etc. So, when we add hydrochloric acid to this one, so what will happen is, see, Mg plus 2HCl gives MgCl2 plus H2. Magnesium reacts with hydrochloric acid to form magnesium chloride and hydrogen. So, similarly, aluminum with hydrochloric acid gives aluminum chloride plus hydrogen is liberated. Zinc reacts with the hydrochloric acid to form zinc chloride plus hydrogen is liberated. Iron with hydrochloric acid gives ferric chloride. So, in this one, which is the common? First we have seen all are metals. These are all metals, isn't it? So, when you come to this one, these are all acid, that is HCl is a acid what we are using. So, they are giving respective chlorides. Metals react with acid to form respective chloride and liberates hydrogen. So, this is the one of the property of metals which reacts with the acids. So, here hydrochloric acid, when it reacted with the magnesium, it forms magnesium chloride. Now, let us go for reaction with the bases, children. How the metals react with the bases? See, aluminum reacts with sodium hydroxide to liberate hydrogen. Aluminum foil, if you take it, is better. So, for wrapping of chapatis and all, they will use no aluminum. So, that you can take and put it in the freshly prepared sodium hydroxide solution. Then you see that some gas is coming out. How will you check for that? If you bring a burning splinter, it gives pop sound. So, there is nothing but hydrogen gas. Now, it is time for the quiz. Let's see. The metal which produces hydrogen gas on reaction with dilute hydrochloric acid as well as sodium hydroxide solution is aluminum, copper, iron, sodium. So, let us see the answer. See, it is aluminum. Non-metal which reacts and catches fire on exposure to air. So, here which is the non-metal in this one, which is going to catch fire? Phosphorus. Very good, children, phosphorus. Next, solution of this metallic oxide changes the color of litmus paper. Sulfur, aluminum, phosphorus, iodine. Sulfur, you have seen that, no? Sulfur which is catches fire and forms sulfur dioxide and it changes the color of litmus paper. You have seen this one. Next, it is time for homework, children. Write down the questions. Children, it is time for telling courtesy for the persons who helped me to do this PPT and all. So, Padmati R. YS National High School, Subramaniapura, Bangalore. She helped me a lot in this making these experiments and all. You have seen that magnesium river burning and all. She helped a lot in this one. Thank you, children. It is presented by me, Lakshmi Narayan Shetty KR, a teacher, science teacher. Thank you very much.